Good day. This is the Professor CBMD PhD. Today is Monday, October 17th, 2022. It is 2:44 and 54 seconds, a.m. Eastern Standard Time. And today's research, immune cells. So let's hop to it here. The newly discovered process brings immune cells up to speed. Study identifies mechanism otherwise found in metastasizing cancer cells. Date October 14, 2022. Source, University of Bonn. The cancer cells use an unusual mechanism to migrate into new tissue and form metastasis there. The same process probably also keeps some immune cells on their toes. According to the study, certain structures, the centrioles, increase in number, and this makes it easier for them to maintain their direction and thus migrate more quickly to the lymph nodes where they activate other immune cells. Like the police, the immune system relies on division of labor. First of all, there are the dendritic cells. They search the tissue around the clot for traces of suspicious intruders called antigens, and if they are successful, they rush to the lymphatic vessels and form there to the draining lymph nodes. There they present their findings to a powerful search team. The T cells, these endogenous troops, now know which enemy to fight, and this attack must take place before the invaders cause major damage or multiply too much. It is therefore important that dendritic cells migrate as quickly as possible to the briefing in the lymph node. And to do so, they form more certain structures called centrosomes. These help them maintain their direction for longer and thus reach the lymphatic vessels more quickly. And the centrosomes belong to the organelles, and these are molecular complexes that are responsible for specific tasks in cells, much like the organs in the body. Normally, there is exactly one centrosome in each human cell. Thusly, shortly before cell division, it doubles. The two copies migrate to opposite poles of the cell and stretch a bundle of fibers between them, the microtubules. With them, they pull the chromosomes, which have also doubled, apart during division. Each of the resulting daughter cells thus receives a complete set of genetic material, as well as one of the two centrosomes. However, centrosomes are also responsible for organizing the cytoskeleton during cell migration. By this we mean fiber-like structural proteins that give the cell its shape and provide it with stability. The cytoskeleton also decides where front and back are in a cell, and that in turn affects its direction of movement. We have now been able to show that dendritic cells form multiple centrosomes as soon as they come into contact with an antigen. The dendritic cells have a problem. They do not know where the next lymphatic vessel is via which they can reach a lymph node. In their search, they proceed accordingly to the strategy of trial and error. They run in one direction for a short while and then change it if they have not encountered a vessel in the process. The more centrosomes they have, the longer they stay on course before continuing to search in a different direction. The researchers were able to show in computer simulations that this allows them to find the lymphatic vessels much faster than they normally would. In the process, the proliferation of centrosomes adjusts their staying power just right so they don't stick too stubbornly to their direction. This would increase the risk of going astray and getting completely lost. The mechanism identified in the study was previously completely unknown in healthy cells. Cancer cells were assumed to use it to form metastasis. However, the multiplied centrosomes must not be freely distributed inside the cells. Otherwise, they would severely disrupt functions such as cell division in both tumor and dendritic cells. The organelles therefore congregate at a single site. They cluster. And there are now agents that disrupt the clustering of centrosomes. As a result, the cancer cells can no longer divide correctly, but die. However, it is also possible that these substances interfere with the immune system. After all, the centrosomes cluster there as well. Researchers tested several of these agents in cell cultures. Researchers actually found evidence that they can significantly impair the effectiveness of the immune defense. And if that will be confirmed in clinical trials, it would be bad news, as there could be considerable side effects if the active substances were used in cancer therapy. And this is the professor of microbiology, bioinformatics, and pathophysiology. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have a great day.